So today we will discuss about some general methods of preparation of alcohols. In the last segments we saw the classification of alcohols and phenols. So today we will discuss about what are the general methods by which alcohols can be prepared. General methods mean on a small scale in laboratory or whenever we have to prepare alcohols on a small scale, then it is called general methods. And today we will see 5 general methods of preparation of alcohols. So we are going to see the general methods of preparation of alcohols. So we are going to discuss about some of the general methods which are being used for the preparation of alcohols generally. So there are 5 methods by which alcohols can be prepared on a small scale. 5 methods. First is from haloalkanes, or we can also say that from alkyl halides, that are common names. Second is from Grignard reagent. We already know about Grignard reagent, an organometallic compound manufactured by Grignard and so-called Grignard reagent, most common in organic chemistry. Third is by hydrolysis of esters. Fourth is from primary amines. How can we prepare alcohols from primary amines? And the last one is by reduction of carbonyl compounds. And in this carbonyl compound, we will take example of 4 types of carbonyl compounds, that is aldehyde, ketone, ester and carboxylic acid. So these are some of the general methods of preparation of alcohols. First is from haloalkanes, or it is also called alkyl halides. Second is from Grignard reagent. We will see how we can prepare alcohols from Grignard reagent. Third is by hydrolysis of esters, means when we will treat esters with water or hydrolyzed esters. Fourth is from primary amines, 1 degree amines. And last one is by reduction of carbonyl compounds. That is, we will see 4 types of carbonyl compounds, that is aldehyde, ketone, ester and carboxylic acids. So we have to discuss all of these in detail. So we are starting from the first one, that is from haloalkanes. We are going to start the first one, that is from haloalkanes. So let us see the first preparation, that is from haloalkanes or alkyl halides, as we can say according to our convenience. So this is our haloalkane Rx. When we treat haloalkane with NaOH or KOH, so this halogen atom and this sodium atom is eliminated in the form of sodium halide, and this R forms a covalent bond with this OH group, means our ROH is formed, and this is nothing but alcohol. So let's take one example. Let us assume that let R be our methyl group, X let us consider Br atom or bromide atom, and when we are treating this with NaOH, so this is eliminated in the form of sodium bromide NaBr, and this CH3 gets attached with this OH group, leading to the formation of methanol. So this is the best method This is the first method how we can prepare alcohols from haloalkanes. When we treat haloalkane with NaOH or KOH, then this sodium forms a bond with X halogen atom of Rx, and it is eliminated in the form of NaX, and this R forms a covalent bond with this OH, leading to the formation of alcohol. Let's take one example. Let the R group be CH3 methyl group, X be bromine atom, and when we are treating with NaOH, this Na reacts with Br. NaBr is eliminated in the process, and this CH3 combines with this OH group, leading to the formation of methanol. But this process has a limitation. The limitation is this, that for the preparation of alcohols from haloalkanes, the haloalkane should be primary. If the haloalkane is secondary or tertiary, then the compound will change. We should normally get alcohol, but the mechanism will change. Mechanism will turn to elimination, and the process will change, and the compound will be alkene in spite of alcohol. Let us take one example. We are taking one example of CCH3, which is tertiary alkyl halide, Br. Fine. So we are modifying this one, this CH3. I am saying this is CH2, H hydrogen atom. Again, this is CH3. When we are treating with NaOH, so it is eliminated in the form of NaBr. And one more thing, this OH combines with this proton H plus ion and forms water, H2O. This hydrogen will be eliminated in the form of proton by giving its 2 electrons to this carbon atom, and a carbon ion is developed, which further donates this double bond, and a double bond is formed over here by hyperconjugation. Means we will get CH3 CH2 plus H2. This is our alkene. Fine. So this was our first process wherein we manufacture alcohol as the product from haloalkanes. When we are treating haloalkane with a NaOH or KOH, then NaX is eliminated and ROH or alcohol is formed. We took one example, but there is a limitation of this case, that haloalkane should be primary. It should always be primary in nature, not secondary or tertiary. If the alcohol is primary, if the haloalkane is primary, then our mechanism will be substitution. But if our haloalkane is secondary or tertiary, our mechanism will be elimination. The mechanism will change and the product will also change. Like we have taken here a tertiary, this is our tertiary haloalkane. When we treat tertiary haloalkane with NaOH, then this NaBr is eliminated. This OH combines with this proton and leads to the formation of water molecule. And this proton is donated in the form of H plus ion, because this hydrogen atom donates its 2 electrons and a carbon ion is developed, and it is eliminated in the form of H plus ion. Protonation will take place, and this double bond, this electron further hyperconjugates and leads to the formation of double bond over here, which we are seeing here. And since a double bond is formed over here, so it means it is an alkene. So it is our double bond. Okay. So this was our first process wherein we can generally prepare alcohols from haloalkanes on a small scale. So it was seen that alcohols can be prepared only when our haloalkane is primary. If the haloalkane is tertiary or secondary, then the mechanism will change. Mechanism has to be substitution for the process of alcohol formation. But if the haloalkane is secondary or tertiary, then the mechanism will change to elimination and alkene will be formed in place of alcohol. Right? So let us move towards second process. Second process was from Grignard reagent. From Grignard reagent. So let us see how the process begins of Grignard reagent, formation of alcohol. First, I will give the general view how the reaction proceeds. Like if this is our carbonyl group or carbonyl carbon atom containing double bond. So this is our carbonyl group. Fine. When this is treated with RMgX, this is our Grignard reagent, general form of Grignard reagent. We know that there is a partial charge over MgX and partial negative charge over R group. Again, here we know that the oxygen atom is more electronegative as compared to carbon atom. So it will attract the shared pair toward itself, and here we will get 2 electrons and a negative center would be developed or a carbon ion will be formed. So the next step would be, so this is having a negative part or carbon ion, and the same amount of positive charge would be developed at this carbon atom. So this MgX will be attached to this oxygen atom and this R group will attack this carbon atom. So our compound would be like this, carbon double bond. This double bond will be converted into saturated oxygen single bond, and this MgX would be attached to this, and this R group will be attached to this carbon atom. Okay. Now in the next step, we will move forward. We will hydrolyze it, we will react it with water in the presence of acid, that is H plus ion, and this process is called acid hydrolysis. This process is called acid hydrolysis. So we know that when water is present, it will be dissociated in the form of H plus ion and OH minus ion. And we know that so the bond will be cleaved from here. OMgX bond will be cleaved, and the positive, since we know that MgX part has partial positive charge and this has negative charge. This has positive charge and the oxygen has negative charge. So the positive part of water will be attached to this oxygen atom, and the OH group will attack this part, and the bond will be cleaved from here. Bond will be broken from here, and we will get two components. First will be carbon double bond, then R, and this will form OH, that is our alcohol OH, plus this will form MgXOH, MgOH and X. Fine. So this is our alcohol, so that is our prime product, and this is called hydroxy magnesium halide. Hydroxy magnesium halide. So this is the general process how alcohol can be prepared from Grignard reagent. Let us see once again how the process continues. So this was our carbonyl group containing a double bond. We know that oxygen atom is more electronegative as compared to carbon atom. So it will attract the shared pair of electron towards itself, due to which one bond, this pi bond will be broken, and the 2 electrons generated from the breaking of pi bond will be collected near oxygen, these 2 electrons, and the negative center or carbon ion will be formed. Because carbon atom has a deficiency of electron, so an equal number of positive charge will be developed on this carbon atom. Now this is our Grignard reagent. We know Grignard reagent has the form RMgx. We know that a partial positive charge is present on the MgX part and a partial negative charge is present on the alkyl part or R part. So this positive part will attack this oxygen atom which is having negative polarity, and this R group will attack carbon which has positive polarity. So if the attack has been taken place, so this carbon was already present carbonyl group and this R got attached over here with this carbon atom, and this MgX group got attached with this oxygen atom, leading to the formation of OMgX. Now when we hydrolyze this in the presence of H plus ion, this process is called acid hydrolysis, and we know that water is hydrolyzed or water is shaped in the forms of H plus and OH minus ion. So the H plus part is collected to the negative part, that is oxygen part, and OH minus part will attack the positive part, that is MgX part. So the bond cleavage will take place from this part in between the two parts, that is OMgX, and leads to the formation of Cr, and this forms OH, that is our alcohol, and this MgOHX is separated in the form of hydroxy magnesium halide. So this is the general formula or the general process how alcohol can be formed from Grignard reagent. Fine. So now we have to form all the 3 types of alcohols, that is primary alcohol, secondary alcohol and tertiary alcohol from Grignard reagent. So we will one by one deal with all the 3 types of alcohols, that is primary, secondary and tertiary, how we can prepare all the 3 types of alcohols from Grignard reagent. So if we have to make primary alcohol, we will take the starting material, that is formaldehyde. We will take the starting material as formaldehyde. When we have to make secondary alcohol, then we will take the starting material as acetaldehyde. This is also called methanol, and this is also called ethanol. And when we have to prepare tertiary alcohol from Grignard reagent, we will take the starting material acetone or propanol. So we can make all the 3 types of alcohols from Grignard reagent. When we may have to prepare primary alcohol, then we will take the starting material as formaldehyde, also called methanol. When we have to make secondary alcohol by Grignard reagent, then we will take the starting material as acetaldehyde, also called ethanol. And when we have to prepare tertiary alcohol by Grignard reagent, then we will take our starting material as acetone, also called propane. So this was the general process how we can prepare alcohol from Grignard reagent. So let us see how primary, secondary and tertiary alcohol can be prepared by taking these as starting materials and a suitable Grignard reagent.